In this next video, we're going to take a look at the probability of compound events. We like to think about these compound events using the term AND. For example, if we use one coin and one dice, we can calculate the probability of getting ahead and rolling a 4. We often use diagrams to calculate the probability. In this case, we're going to take a look at a tree diagram. A tree diagram is a helpful way to show every possible outcome there is. First, let's use the first two branches of our tree diagram to calculate the probability of getting ahead. Remember, there are only two possible ways to get ahead. There's either a head or a tails. Next, we can branch off more branches from the heads side because there are 6 possible outcomes for a 6-sided dice. There's a 1, 2, 3, 4, 5, and 6. Similarly, for the tails side, we can also roll a 1, 2, 3, 4, 5, or 6. Now that we have our tree diagram set up, we can now answer our question. What is the probability of getting ahead and rolling a 4? First, we have to roll ahead. So we'll use that part of the tree. Next, we need to roll a 4. How many ways are there to do this? Well, if you take a look from the top to the bottom, how many ways are there to do that? If you see, there are 12 possible outcomes, and there is only one possible way to do that. So the probability of getting ahead and rolling a 4 is 1 out of 12. We can think about this in another way, and we can still get the same exact answer. We know the probability of rolling ahead is only 1 out of 2. Next, the probability of rolling a 4 is only 1 out of 6. Notice that if we multiply the two green fractions together, we get the equivalent answer in red, shown above. Because 1 times 1 equals 1, and 2 times 6 equals 12. As a takeaway for the compound AND, if we compute individual probabilities for the AND, we multiply those individual probabilities together to get us the total probability. If you're not going to do it that way, you can simply use a tree diagram. Either way, you should get the same answer in the end. Let's try another example. What is the probability of getting a tails and rolling an odd number if we use a dice? Once again, we can demonstrate this by using a tree diagram. Remember, an odd number is just 1, 3, or 5. Those are the only possible numbers on a 6-sided die. First, the probability of getting a tails is right here. It's 1 out of 2. Well, forget about that for right now. Let's just figure out the total ways we can get the tails and rolling an odd number. Well, how many possible outcomes are there? There are 12 possible outcomes. So we know that if we're getting a tails, we're in the bottom half of the tree, and if we're rolling an odd number, it has to be 1, 3, or 5. So there are 3 total ways to do this, and there are 12 possible outcomes. Well, that gives us 3 out of 12. Finally, we can simplify our answer. This becomes 1 out of 4. We just demonstrated that we can calculate this probability using a tree diagram. What if we use the previous slide to demonstrate our understanding? Again, we're going to use multiplication. So, the first probability we have to worry about is the probability of getting a tails. The probability of getting a tails is just 1 out of 2. The probability of rolling an odd is just 1 out of 2 as well, or 3 out of 6. As you can see, we computed our individual probabilities, and all we do is multiply the individual probabilities together. Doing that we'll get 1 times 3, which gives us 3, and 2 times 6, which gives us 12. Remember, we can just simplify 3 out of 12 to become 1 out of 4. We just demonstrated our understanding using a tree diagram or a different method. Again, you could use either method, but a tree diagram is much more useful to use.